We're still doing graphing, so the instructions for this, for E and F, are the same as it was on the previous page, which is to graph these lines. So when I look at this, some people go, oh, special case. No, it's not a special case. Watch. Look at the difference. So on this page, this was a special case. Y equals 4, just a number. This is a special case. And what do I mean by special case? Horizontal and vertical lines. That's what I consider to be special cases. This is x equals 2. So x equals a number, y equals a number. Those are my special cases. Now, this is not a special case because of the x. So this is still y equals mx plus b form. So this is actually y equals mx plus b form. People go, wait, it doesn't look right. But the reason why it doesn't look right is because it has an invisible plus 0, which we don't write in their equation, but you can fill it in for yourself when you're graphing. Just for now, eventually you won't be filling that in. But for yourself, you kind of go, oh wait, I know it's 0. So then I would write b equals 0. There you go. And then what else do we know? We know here that m is negative 2. And whenever I get a whole number for m, I always write over 1. Because then I know my rise is negative 2 and my run is 1. So this is the part that tricks you. So you go, wait, that's not y because I'm supposed to be. And the reason why I know it's not a special case is because there's an x. Right? So the special cases would be y equals, so if I had given you y equals negative 2, that's special. If I give you x equals, say, negative 2, that's special. This one's not the special case. It's the regular y equals mx plus b because there's an x there. So that is the slope, and the y-intercept is 0. That's why it looks different. Right. So if this is a negative 2 rise, that means I'm heading down 2. That's a positive run, which means right 1. And again, if you want to make them both backwards, we could move the negative down here, and that would flip both of the arrows. But I'll just do it this way. So here, the first step that you're going to do is plot the b equals 0, which is 0. If my y-intercept is 0, it's at 0. That's our first one of this one. And then from this point, we want to rise negative 2, so that's down 2 squares, 1, 2, and right 1. Down 2 squares, 1, 2, and right 1. So down 2, right 1, down 2, right 1. So from here, down 2, right 1, down 2, right 1, and I fill the grid. Down 2, right 1. That should give me a nice straight line. You can draw your line like this. If you want to go backwards, you can do more of the backwards pattern. But if you don't want to, I still want you to fill the grid with the line. Right? I prefer to do a few points backwards because I'm not sure how straight this is. So I am going to go backwards. What do I mean by backwards? I put both the arrows the other way. So it'll be up 2, back 1. So up 2 from here, up 2, back 1, up 2, back 1, up 2, back 1. It is a good one, up 2, back 1. It is a good idea to understand how to do it backwards and forwards. Okay, it is a skill that I need you to have eventually. So try to do this. And then put the arrow on both ends. We talked about this in the other video. So I want a ruler and I want arrows. I want you to fill it as much as possible. So you can see arrows at both ends. And yes, we do mark that stuff. I'm going to just circle it to remind you. It has to be with a ruler. Okay, so this is the stuff that we do mark you for, arrows on both ends. Okay, so this next one, so I hope that's all right. Can you see everything there? Okay, this next one, y equals mx plus b form. So I know that here m is negative 1. I'd like to put it on the top over 3. Write the number in front. And then this one here, that is my b equals, and it looks like positive 5, so 5. So that immediately tells me I put the dot on 5. So hopefully you're seeing this pattern now. Dot on 5. This is a rise of negative 1. So rise negative 1 means down 1. And my run is positive 3, so right 3. Okay, so down 1. So from this point, down 1. So from this 5, count 1 square down and run 3. 1, 2, 3. 1 square down, 1, 2, 3. 1 square down, 1, 2, 3. And again, from backwards, it would be back 3, up 1. Back 3, up 1. Right, so hopefully you can see the pattern now. practice this again. I know I went a little bit faster in this last one. Practice it again and make sure you're comfortable. I want the arrows on the end with the ruler. Okay, you want to be comfortable drawing this, so slow it down if you need to replay the video. All right, so that is graphing. We're going to go back to some more algebra with this. So here on the bottom of the page, I said, so that's our graphing stuff. On here, for example 4, I'm asking you to find the x and the y-intercept of the following. And I just gave you this. There's no grid, so I'm assuming that you're doing this algebraically. The only time we want you to use a grid is if we give you a grid, so there's no grid. So I have these two equations, linear equations. They're kind of mixed up. It's not in y equals mx plus b form, right? So you can see now we're going to go and combine this chapter with chapter 4, and we're going to mix up the equations. So it doesn't have to be in any particular form. And I'm going to ask you to find the x-intercept and the y-intercept. We know these two definitions. This is x-intercept, and this is y-intercept, right? So we know these two definitions. So I do need you to know x-intercept and y-intercept definitions. So over here, x-intercept, if it's on a graph, I can just read it off the graph. I can't read this off the graph. So for the x-intercept, I need you to remember that whenever we plotted the x-intercept, that was when y equals 0. So that is a definition you need to know. You have to know this. Okay, so you have to know x-intercept was when y equals 0. The y-intercept was when x equals 0. So when you think about the intersection points on the line, so I'm just going to do this. So x-intercept and the y-intercept. The x-intercept is always going to be some point on the x-axis, which means the y was 0. The y-intercept will always be some point on the y-axis, which means x equals 0. Right? So when you sub that in, we know that this value here was 0, y, and this value here was x and then 0 for the y. That's what they're saying. So algebraically, x-intercept is when y equals 0, and we're going to plug that in. So I'm going to do my title. Remember, everything needs to be titled. When you're writing a solution, you're telling the story. So I'm going to go x-intercept. And you can use a short form, x-int, like that. For my x-int, it's when comma y equals 0. So I usually write that as my title. For my y-intercept, comma, that'll be when x equals 0. So I use that as my title. And again, we're going to use the same intercepts idea through our future mathematics in high school, so you're going to need these definitions. So x-intercept is when y equals 0, y-intercept is when x equals 0. We're going to substitute this in. So wherever you see y, you're going to sub in 0. So go to this equation, and we're going to go 4x minus 5, and wherever you see y, you're plugging in 0. What do I mean by plugging in? You're substituting. Plus 20 equals 0. So wherever I see the y, you're subbing that in 0. 5 times 0. So when I sub it in with a bracket. So you'll notice I subbed it in with a bracket. Okay, I want to see the bracket. When you have 5 beside that variable, 5 beside the variable, it's multiplication. 5 times 0 is 0. So I'm going to cross that off, and I know it's 0. So this will be 0. I'm going to rewrite this, and I'm going to go without the 0. I'm going to write 4x plus 20 equals 0. I do want to see that step. Eventually, some people might be like, oh, I want to skip steps. So eventually, I'll let you skip more steps. In grade 9, we want to see everything. Right? We want to see all the proper steps. And eventually, in upper grades, I'll be like, yeah, you don't have to show me a little bit of this. But this year, I definitely want to see the substitution. You cross it off and say, oh, that's 0. It's gone. And then I write down what's left over. Then I'm going to solve. You'll notice that, look, this has the equal 0, so I'm putting the equal 0 here. I'm going to hop this 20 over that equal sign. You don't have to show the arrow, but when I'm solving, when it hops over, it becomes negative 20. Then, when we were solving from chapter 4, we divide both sides by 4, and then we're going to get x equals, that crosses out to be 1, and then this will be negative 20 divided by 4, and that'll be negative 5. So then my x-intercept right? My x-intercept is going to be at -5, 0. -5, 0. We're going to do that again, and we're going to do that with the y-intercept. Sorry, I'm just drawing a line so we can separate it. We're going to do the y-intercept. So for my y-intercept, wherever I see x, I'm going to plug in 0. So I'm going to go 4, and I'm plugging in 0, substituting in 0 wherever you see the x. So in this equation, we're going to go minus 5y plus 20 equals 0. So you'll see x equals 0 went in here. I wrote everything. These are two separate equations. So I did the same, took this equation, subbed in 0, solved it. That's done. Now I'm going to do y-intercept. I'm going to put 0 into the same original equation. So start it over and put 0 in. 0 times anything is 0. And I'm going to rewrite it. So these are two separate calculations. Separate. So these are two separate calculations. We're going to do this one, and we're doing this one separately. Okay, so we start the question again, and we put 0 in for x. Solve. When we bring this over the equal sign, it becomes negative. And when we solve, we divide both sides by whatever's in front, which is in this case -5. That cancels out, and we're left with y equals, now -20 divided by -5 is a positive 4. So therefore, this is 0, 4. 0, 4. So I have my x-intercept at -5, 0. That's one coordinate. My y-intercept at x equals 0, so 0, 4. So that's 0, 4, and this is 0 goes in for the y, so -5, 0. Two separate points. So these are two separate, completely separate calculations that we're doing. Let's try that again. So I'm going to try it again. Sorry, I used up too much room here. Okay, so I'm going to try this again. I'm just separating it so you can read. I'm going to do this question B. Same question. I want x-intercept and y-intercept for this equation now. Okay, so let's do it again, see if you can follow. I want my title first, so I always want a title, so beautiful title to tell me what's happening. Otherwise, it's a bunch of calculation and I can't follow. Right, so I want you to tell me I'm finding the x-intercept, which is when y equals 0. That's my title. My second title, you can set it up, is my y-intercept, which is when x equals 0. So those are my two sets, separate. So I go to this equation. Wherever I see y, I'm going to substitute in 0. So 3x plus 2, you don't have to use a color, but I'm going to show you what I'm doing, 0. So wherever I see y, I'm subbing in 0. Plus 10 equals 0. 0 times anything will be 0, so that's gone. You can put 0 there, or you can just cross it off. Rewrite what's left over, like that. So I wrote it without that middle part. Bring this over. When you, also over here. So pause for a second. You'll notice I'm setting up the equation just like what we did in chapter 4. The equal sign goes in the middle. Try to line it up as best as you can. Doesn't have to be perfect. And look, nothing is here. There's no extra equal signs on this side. Same thing here. I tried to line up my equal signs here. Nothing is on this left side. No double equal signs. Okay, same thing as I'm going to do here. So I'm bringing that over the equal sign. So I'm going to get 3x is -10. Divide both sides by 3. Does it have to be a whole number or an integer? No, it can be a fraction. Fractions are our friends. We love fractions. Leave it as a fraction. So leave as a fraction. Do not change it to a decimal. We do want you to leave it as a fraction. Always, always, always. Again, habits for future math. So -10 over 3, x is that, comma, 0. We said 0 is y. That's 1 point. Okay, so that's beautiful. And now we're going to do the same thing for the y-intercept. You don't have to use a ruler to separate. I'm making my notes really neat so you can read it. And then over here, we're taking the same equation, and we're substituting in 0 for x. So wherever you see the x, we're subbing in 0 in a bracket, plus 2y plus 10 equals 0. This cancels out to be 0. Gone, gone, 0. So I'm writing down what's left over. And then I'm going to solve by bringing the 10 over. Hopefully this is following a pattern. When it hops over the equal, it's negative 10. When I want to solve for a variable, I divide by whatever's in front of it. And y equals negative 5. So therefore, my coordinate for this, x is 0, so 0, negative 5. So I get 2 separate points. One more time, please look at your answer here. You should notice that the equal signs are lined up pretty as much as you can in the middle. There's no equal signs here. Here I'm trying to line up my equal signs here. There's no equal signs here, and you have a nice concluding sentence.